Hello, geometry students. I appreciate you finding time to get your notes taken care of. Today we're going to be taking our discussion of surface area and volume one step further by looking at what we call comparative surface area and volume. Please copy down the title as well as the objective for today. And that objective is to apply previous surface area and volume skills in order to compare two solids to each other. Now, as we said, or as I said just a moment ago, we're going to be looking at it in a little bit of a step further, and this is the idea of perhaps one volume trying to fit into another, or perhaps certain polygons, which are two-dimensional shapes and have two-dimensional area, trying to cover a particular solid. So we have two-dimensional area trying to cover two-dimensional surface area. So it's going to involve us using our formulas a bit more, possibly having to figure out more than one shape in the middle of a single problem in order to figure out what's going on. Okay, so let's take a look. Comparative surface area and volume deals with situations, pardon me for the misspelling there of the word situations, got my A and my U backwards. Okay, deals with situations where one solid is becoming part of another. Okay, and like I said, this is the idea that maybe we have a larger container's volume trying to fit into a smaller container, or vice versa, or we have one area trying to cover another area, or perhaps a big area, and we want to know how many smaller areas it will cover, things like that. So let's take a look at a couple of examples together, and then I'll leave one example for you to try at the end. Okay, the first one we're going to look at is this. If cylinder A is being filled with cylinder B, then how many cylinder B's will it take? So let me give you the diagram to go along there with it so it'll make a little sense. If cylinder A is being filled with cylinder B's, how many cylinder B's will it take? And basically, how many cylinder B's will it take to fill up cylinder A? Okay. Well, obviously, what we need to know is we need to know how much volume is in cylinder B, and if it's going to be dumped into cylinder A, we need to know the volume of cylinder A so that we can figure out how many B's can be dumped in there before cylinder A is basically overflowing. Okay, so these are volume questions. We need to know how much stuff can cylinder A hold and how much stuff can cylinder B hold. Okay, well, we have formulas for volume of a prism, and the formulas are big B little h. Okay, so if these are being compared to each other, then ultimately the question we need to be able to answer is volume on the left is equal to how many volumes on the right. Okay, so we're going to take the big B little h formula, we're going to adjust it so that it will accommodate these cylinders, and of course big B, in the case of a cylinder, our base is a circle, so our formula for the area of a circle is pi r squared. So in each of those formulas, I took big B out and put pi r squared in each one of them. Now with these formulas, with these comparative volume and surface area questions, very important to keep your formulas and your particular shapes, keep them straight. Okay, remember that in this formula, that equation that you're looking at right now, there are two r's in that equation, but they are not the same r's. One r came from cylinder A, the other one came from cylinder B, so make sure you plug in correctly. Also in that equation, there are two h's, but they are not the same h. One height came from cylinder A, one came from cylinder B, so keep that information straight. Okay, so let's plug in. It looks like we have pretty much everything that we need here. The radius and the height from cylinder A are 9 and 30. The radius and the height from cylinder B are 4 and 12. Okay, so just plugging numbers in. Of course, you got your variable in there. I've got a question mark sitting there, but it could be anything. X, Q, pink flamingos, whatever. I just put a question mark. And when we clean up the math a little bit, we end up with these guys. Okay, so we have 7,634.07 is equal to how many 603.19s? Okay, so obviously it's a division question. We need to know how many times can 603.19 go in to 7,634.07. Okay. When you do the division, we end up with 12.66. Okay. Now, with the comparative surface area questions, a lot of times you need to consider the question when it comes time to actually answer it, because we may not want to leave this as a decimal point. The question asked if cylinder A is being filled with cylinder B's, how many cylinder B's will it take? Well, we ended up with basically 12 and 2/3. Okay, so essentially we are saying that, hey, it took more than 12, but not as many as 13. So if we were to shut the problem off at 12 cylinders, 12 cylinder B's, would cylinder A be filled? And the question is no. There would still be a little bit of space left over because we needed 2/3 of another cylinder. Well, we don't get 2/3 of cylinders, okay, when it comes to trying to fill one area up with another. Okay, so we are going to need the next cylinder B to get the job done. So our answer is 13 cylinder B's will be needed. Now keep in mind, it's not rounded up just because it was a situation to round up. It was the fact that we needed the next entire cylinder to get cylinder A to be filled. So even if that had been 12.01, we still would have had to answer 13 cylinders because 12 would not have been enough to fill it up. Okay, let's look at another one together. A rectangular prism is to be covered with square cloths. How many of the cloths will be needed to cover the prism? Well, this is a surface area question, obviously. Okay, the problem is talking about covering. That is area. That's a surface area question. So we are going to need to know what is the overall surface area of the rectangular prism, and we are going to need to know the area of the little square cloth. Okay, so when it comes time to figuring out the problem, well, here's the question that we are trying to answer. The surface area from the left equals how many of the areas on the right? Okay, well, obviously finding the little area of the little square on the right is no challenge at all. Surface area of the prism on the left, we need to know basically the areas of all of the sides of the rectangular prism so that we can add them all up. So essentially, here's what we're trying to figure out. Our surface area on the left, we have two sides that are going to be the same, and then two more sides that are going to be the same, and then two more sides that are going to be the same, and then we can add them all up. So all we have to do is plug in the correct dimensions for the three different sized sides. And for the area on the right, no big deal. Okay, so plugging the numbers in, okay, on the rectangular prism, we have side lengths of 6 by 11. We have side measurements of 9 by 11, and we have side measurements of 16 by 9. The square on the right is obviously 7 squared. Okay. Well, figuring out these numbers here, 16 by 11 is going to be 176, 9 by 11 is going to be 99, and 16 by 9 is going to be 144. And of course, 7 squared over there is going to be 49. Okay. Well, by adding up these three guys from the surface area on the left, we can find our total surface area, and our total surface area is 419. Okay, so now that we know the individual areas, we can kind of plug back into our original formula that we had there. Surface area equals how many areas? Well, we have those numbers now. 419 equals how many 49s? Okay, well, obviously we've got a little division problem there. So we're going to take 419, we're going to divide it by 49, and at the result of that, we have a decimal point. 8.55 is the how many. Okay, so we need a little common sense here. Let's think about it. Okay, we're not going to get 8.55 of the cloth, so we need to decide, is 8 cloths good enough, or do we need the 9th cloth? Okay, well, if we only go with 8, there's going to be a little bit of surface area still left over. That's how come 0.55 was actually part of the problem there, part of the answer. So we are going to need the 9th cloth. So our answer is 9 square cloths are going to be needed in order to cover the prism's surface area. Okay, I've got one more problem here for you, and I want you to give this one a try. Okay, please do not do the I don't get it. Use the other two examples as kind of a template for how to move through these problems. That's why I give you examples, so that you can try to get it. A cone is leaking from the vertex. In order to save the fluid inside of it, hemispheres are used to catch the drips. How many hemispheres will be filled? Okay, so copy down the question and the diagram that goes along with it. Try to determine what kind of a formula is going to be needed in order to accompany this problem. Is it going to be a volume question, or is it a surface area question? Okay, what's the equation going to look like? Which volume or surface area is trying to go into the other? The variable that's in the problem, where does it have to exist in order to make sense for this question? What formulas are involved with that volume or that surface area? So when you can plug in to your equation to figure out what's going on, and then see if you can solve the equation. Okay, that's all we got for today. So hopefully it's not anything new. It's old formulas and old information, just a different way of looking at it. So please give this problem a try. You should have some extra time since the notes were not long. Bring that with you to class, and I appreciate you getting your notes taken care of, and I'll see you at school.